Hey everyone, so this is going to be day one of our remote learning plan, and I thought it might be a good idea to review some of the things that we've been learning about over the past couple weeks. So before we left for this mini break, we were talking about how to factor using a variety of methods, and then we started switching towards how we could actually use the inverse operation of factoring with multiplication. Right? And while we were doing all of these skills, we were practicing a lot of different polynomial operations. So let's review some of the ones that we talked about. So whenever we were multiplying using FOIL or the box method, which we're going to go over in a little bit, right? We covered this idea of combining like terms. And when we combine like terms, we're on the lookout for the same variable raised to the same exponent, or just regular old numbers, right? So when I'm talking about same variable to the same exponent, let's say that I have, let me write this in red. Let's say that I have the variable x, right? The only other like term to x would be something like 4x or 5x, right? It would not be something like x squared, because even though it has the same variable, the exponent is different. The exponent for x is 1, and the exponent for x squared is 2, right? So we want to make sure that we're having the same exponent as well. And we know that we can always combine by adding or subtracting regular old numbers, like we can do 4 plus 2 or 2 plus 2, right? And so when we combine like terms, our terms stay the same and only our coefficients change, right? So let's look at this example here. So I have 4x squared plus 7x minus 8 plus negative 2x squared minus 3x plus 7, right? So when I look over here, I first see that one of my first like terms is 4x squared and negative 2x squared, right? So I can actually combine those like terms by doing 4x squared plus negative 2x squared, which is the same as 4x squared minus 2x squared. And I know that 4x squared minus 2x squared, I'm just changing the coefficient, so it's just going to change to 2. And I'm going to keep that term x squared, right? My next term that I see in my expression is positive 7x, and my like term to that is going to be negative 3x, right? Because they both have an x, and it has the same exponent 1, right? So 7x plus negative 3x, which is 7x minus 3x, is going to be 4x. Once again, I'm only changing the coefficient. I'm only changing the number in the front, not the actual term x itself, right? And I have these regular old numbers, negative 8 plus 7. I can do negative 8 plus 7, that equals negative 1. So now I have my combined like terms, and I can actually just string them together along to get my new expression, 2x squared plus 4x minus 1. Right, so this is our first type of simplification, right? When I simplify terms, or when I simplify expressions, I'm using my operations. In this case, combining like terms is actually a really fancy way of saying addition. So this is addition or subtraction with polynomials. Oh, not subtractions, just subtraction. Right. So, try our next one. So we're given this example now, where we're asked to combine like terms for the expression below. So we're simplifying by combining like terms. So we first want to identify what our like terms are, right? So when I first look at my first term, 15y, the only other expression that only has a y is 6y, right? And because I have that plus sign in front of it, I know that I'm going to be adding the 6y. So I'm going to combine these two like terms, 15y and 6y, to get 21y. So you might be asking, hey, I see a y over here. Why can't I combine it with that, right? And the reason why I can't combine it with xy is because xy has another variable attached to it, x, right? And we may be able to combine it after doing some factoring, which we'll see later on. But just as it is right now, we can't actually combine these terms because the coefficient for y is another variable, which is x. And we know that x and y are not like terms, so we can't combine those together, right? I'm going to move on to my next term that I see that I haven't combined. And I'm going to use blue for this, right? And I'm going to attach a sign to it, right? So I have negative 3x, right? And I don't see another like term to negative 3x for the same reason why I knew that xy wasn't going to be a like term to y, right? So I'm just going to bring down the minus 3x because I don't have a like term to it. And then I'm going to bring down this plus xy because it's lonely, doesn't have a friend. that I can actually combine it with, right? So this would actually be my simplified expression after I combine like terms. Now later on, we can use factoring in order to help us further simplify this, but for now this is good enough, right? So we covered one type of operation with polynomials, which was adding and subtracting using the combining like terms method, right? And now we're going to be covering a different operation, which is just multiplying polynomials, right? And when we multiply polynomials, we have a few different methods of actually doing it. And the first one, that's probably the simplest one that we're going to see, is called the distributive property. And with the distributive property, right, it's one of the first properties of equality that we covered in the beginning of Algebra 1. And it tells us that whenever we have a coefficient, when I say coefficient, I mean something that's hanging outside of parentheses, right? Whenever we have a coefficient of a group, like 3 plus 4y, when I multiply that coefficient to everything inside that group, I'm going to create an equivalent expression, okay? So this is telling me if I have this coefficient x and I multiply it to 3, then I get 3x. If I multiply x with my other coefficient, 4y, I'm going to get 4xy. And then when I combine those terms together to get 3x plus 4xy, that's actually an equivalent expression to what I originally had written down, right? Now, whenever we're working with the distributive property, we want to make sure that we're including whatever signs are in front of the term, right? So we want to watch our signs, okay? And I actually made a little bit of a boo-boo over here, and this is something that I see happen very often, so let's actually cover what my mistake was over here, right? So I knew that my coefficient in this case was going to be -1. And like I said, I want to multiply -1 to everything inside my parentheses. So I'm first going to multiply -1 times a to give me -1a, right? But then I have my second term, -1, right? So I have -1 times -1. And a negative times a negative is a positive, right? So I got that right. I got a positive over here. But then -1 times -1 is actually +1, right? And some mistake that I made when I was making this, I probably just added by mistake. Right? So I want to make sure that I'm always multiplying whenever I'm using my distributive property. Let me just write that so it's a little bit neater instead of a big giant mess, right? So this should be -1a plus 1, right? So you want to make sure whatever your arrows connect to, right, they have to be multiplied together, not added, okay? Let's do a check for understanding, right? So you can pause the video right over here for a quick second for you to work through these 3 practice problems where you're using the distributive property. I really recommend that you circle your coefficients first and then draw your arrows like how we did before, right? So you want to circle your coefficient, draw your arrow to everything inside your parentheses to know exactly what you're multiplying to, right? So take a minute, pause the video here, and work on these examples. Let's work on some of these examples, right? So I have 3 times 4x, right? 3 is my coefficient, so I drew an arrow to every single term inside my parentheses. So I have 3 times 4x, right? And then I also know to multiply 3 times 2. So I know that 3 times 4x is going to give me 12x, right? And 3 times 2 gives me +6, so I'm going to write +6. And this is going to be my fully simplified expression after I've used the distributive property. Let's try out example B. My coefficient over here is going to be -5. And this is another example where I really want to make sure that I'm watching my signs. The first term that I'm going to be multiplying with -5 is y. So -5 times y gives me -5y. Now, I also know that I have another term within my parentheses, this -7. So I want to make sure that I'm multiplying -5 times this whole term, -7. And the negative times the negative is going to give me a positive. -5 times -7 is +35. So my fully simplified expression is -5y plus 35. Finally, my last one, my coefficient is going to be -2, right? And my terms inside my parentheses is going to be 9 and n plus 9, right? So I'm first going to multiply -2 times n, which gives me -2n. And then I want to multiply -2 times 9. a negative times a positive is a negative, and negative 2 times 9 is negative 18. So this should be my fully simplified expression using the distributive property. If you were struggling with this, I suggest that you take a look back at the previous slide and then try out these examples again. And also utilize your peers next to you who seem to be catching along with this material too. So we learned about combining like terms using addition or subtraction. And we learned about one method of multiplying polynomials, which is with the distributive property. So when we use the distributive property, it's typically when we have smaller polynomials, right? So when we're multiplying polynomials with monomials, right? But let's say that we're trying to multiply polynomials with polynomials. Then we might want to up our game, right? We might want to try a more complex method. So one method that we might want to try is something called the box method. And this is when we're multiplying polynomials with polynomials, right? Polynomials times polynomials, right? Poly times poly, right? So let's look at this example that we have over here. I have a binomial, x minus 6. I know this is a binomial because I have two terms, x and negative 6. And I'm multiplying another binomial with it, right? X plus 2, my two terms are x and positive 2. So when I'm doing the box method, right, I first want to draw a box. I'm not going to try to draw it because my handwriting is really bad, right? So you'll see a box on the screen, and you want to place your first group, like x minus 6, at the top of your box, right? After you place your first group at the top of your box, you want to draw a line that's dividing your two terms, right? Do the same thing with your second group, x plus 2, except make it go down the left-hand side, right? Once again, draw your line that separates your two terms. Now, each side of the smaller boxes that you've made is going to tell you what you need to multiply together, right? So over here, we're going to multiply x times x together, and we're going to get x squared. We know that this length over here is actually x because of our previous box that we just multiplied, right? So this is x times negative 6, which gives us negative 6x. We want to continue this process. This is going to be 2 times x. We know that that's x, right? So x times 2 is 2x. And then over here, we know that this is positive 2. We know that this is negative 6. So 2 times negative 6 is going to give us negative 12, right? So after I've multiplied all of my boxes together, I end up getting these four terms, x squared, negative 6x, 2x, and negative 12. I want to write them out and combine them, right? I'm going to combine them with addition. So I have x squared minus 6x plus 2x minus 12. And then finally, I just want to combine my like terms. So we're going to link back to the first skill that we talked about in this lesson. And our like terms are going to be negative 6x plus 2x because these both have the same variable raised to the same exponent, right? And when I add negative 6 plus 2, I get negative 4, and I keep that term, right? I did all that work of combining the like terms and identifying what they were, I might as well keep the like term, right? So my final expression should end up being x squared minus 4x minus 12. Now, I know a lot of people might not like the box method. They might think that it's kind of complicated. And so I have an alternative method for you, right? So the next method that we're going to be covering is going to be dealing with the same type of expression, right? A polynomial times a polynomial. So a poly times a poly, right? But it's just a different kind of method. You're essentially doing the same thing. It just looks a little bit different. So you might have learned something called FOIL, right? This is the way that I learned it when I was in school. But FOIL stands for the order of how you should be multiplying your terms, right? So the first thing that you're going to do is multiply the first terms in each of your group, right? So that F in FOIL stands for first, and the first terms in each of your groups are x and x. So that's what I'm multiplying together to get x squared. Then I want to multiply the outer terms of my expression. So my outer terms are going to be x and 2 because they're on the outside of my expression. Let me actually write this in a different color so we can actually differentiate that a little bit better, right? We have x and 2, right? Because they're on the outside of my expression. So if those are my outside terms in my expression, my inside terms would then be whatever's left over, right? So I'm going to write that in blue. That's going to be negative 6. Remember, watch your signs, and x, right? Negative 6 and x. And then finally, the only combination of terms that we haven't multiplied together yet is going to be 2 and negative 6. So those are the last terms in each of my groups, right? So the last terms in each of my groups are 2 and negative 6, right? To get negative 12. Now, I end up with all these terms, x squared, 2x, negative 6x, and negative 12, right? And finally, my last step is just to use that skill that I covered in my first slide, which is combining like terms. And I know that when I combine 2x and negative 6x together, I get negative 4x. So I end up getting x squared minus 4x minus 12, which is the same expression that I got when I used the box method, right? Gonna give you the same result, just a slightly different way of getting there. So if you think that this is easier for you, then by all means, use this method instead. So let's do another check for understanding, right? Pause the video here for a couple minutes to work through multiplying this problem. Now, it's up to you whether you want to use the box method or FOIL, but choose which one that you want to work with and work through this problem to get your fully simplified expression. All right, you worked through it. Let's go over it together. So I'm going to use the box method first, and then I'm going to do this problem using FOIL, just so that people who are using FOIL can also check whether or not they did it correctly. So for the box method, the first thing that you want to do is actually draw a box. So I'm first going to draw a box. Yep, I know my handwriting is horrible, and I can't draw. Great. Okay, now that I've drawn the box, now I want to put my first group of terms at the top of my box, right? And my first group of terms is going to be my first parentheses, right? So this is going to be 3x minus 5. I'm going to put that at the top, 3x minus 5, right? And so my two terms are 3x and minus 5. So I'm going to draw a line that separates them. Okay, now I want to go on to my next group of terms, which is x minus 10, right? So I'm going to write x minus 10, and I write this in blue. I'm going to write that going down, x minus 10. Remember, I want to separate the two terms, x and negative 10, away from each other so that I can draw that line that separates them. Okay? So now that I've drawn my box with the proper grid lines, now I want to actually multiply the sides of my boxes together to figure out what my area of these smaller boxes should be, right? So I'm first going to multiply x and 3x to get 3x squared. Over here, I know that this side is actually x because it's directly across from where I've labeled this side as x, right? So I'm going to be multiplying negative 5 and x together to get negative 5x. Over here, same kind of deal, right? I know that this side is actually 3x because it's opposite a side that's labeled 3x, right? So I'm going to multiply negative 10 and 3x together to get negative 30x. And then same kind of deal as before. I know that this side is negative 5 because it's opposite the side labeled negative 5. I know that this side is negative 10 because it's, once again, labeled. It's across from the side that's labeled as negative 10. So I'm going to multiply those two together. Negative 10 times negative 5 is positive 50. So now I can write out all my terms, right? I have 3x squared minus 5x minus 30x plus 50. And I see my two like terms here. I'm going to write this in yellow, negative 5x and negative 30x. And I can combine those like terms to give me 3x squared minus 35x plus 50. That should be my final answer, right? If you didn't use the box method, totally understand. When I first learned the box method, I was also a little bit confused. So let's go over the FOIL method, right? Remember, FOIL stands for first, outer, inner, last, okay? Let me erase all the marks that I did. Okay, now that we're starting with a slightly blanker canvas, let's actually work through FOIL. So F stands for the first terms in each of my groups, right? And my two groups are 3x minus 5. Let me label that as red. 3x minus 5 and x minus 10, right? And so the first terms in each of these groups are 3x and x. So I'm going to multiply 3x times x together to give me 3x squared. right? My O, let me change that to blue. My O stands for outer terms of my entire expression. So that means that when I look at my entire expression, 3x minus 5 times x minus 10, it's going to be my first and last term, right? So it's going to be 3x and negative 10. So I have 3x times negative 10, and that gives me negative 30x. Okay, my inner terms, right? This is the inner terms of my expression, going to be green, right? And so those inner terms are going to be negative 5 and x, because they're on the inside of my entire expression. So negative 5 times x gives me negative 5x. Finally, my last terms, I'm going to label those yellow, are going to be negative 5 and negative 10. And these are just the last terms that I've never, that I haven't multiplied yet, right? So I have negative 5 times negative 10. This gives me positive 50. There we go. Right, and then I see that I have two like terms over here, right? I have my first like term of negative 30x, and then I have this other like term of negative 50x. So using my magical powers of combining like terms, I see that these two actually simplify to negative 35x when I combine them together, right? So my terms at play are 3x squared, negative 35x, and plus 50, right? So my final expression should end up being 3x squared minus 35x plus 50, right? Lo and behold, I get the same expression that I got with the box method. So whichever method you are more comfortable with, by all means, use that method, right? So if you are having trouble with this check for understanding, please go back to the previous slide or watch this explanation again. And if you're still having trouble, please contact me by giving me a call. All right, guys, we're getting close, right? So we haven't formally covered how to divide polynomials by monomials, meaning an expression with a lot of terms, right, versus an expression with just one term, right? Mono means one, poly means many, right? However, when we've been doing our factoring work, right, we've actually been using the skill of dividing polynomials by monomials pretty often, right? So when dividing polynomials, an expression with many terms, with a monomial, an expression with only one term, just break it up and remember your exponent rules, right? And we're going to be covering exponent rules on days 4 and 5, right? But it's something that you're actually pretty familiar with already, right? So my first example, right, x to the 6th minus 4x to the 4th plus 3x squared is all divided by 5x squared, right? So I'm going to break it up by terms. So my first term here is x to the 6th. My second term is going to be minus 4x to the 4th, keep your signs. And then my last term is 3x squared. And everything is being divided by 5x squared, right? So I'm going to make sure that anytime I have one of my terms, I'm going to divide it by 5x squared, right? So my first that I have over here is x to the 6th divided by 5x squared, right? So when I have x to the 6th, right, I know that my actual coefficient is going to be 1. Let me see if I can zoom in a little bit more. Right, my actual coefficient is going to be 1, right? Actually, let me write that in blue. Right, and when I do 1 divided by 5, that's already in simplest form, right? So I can't really simplify it anymore, so I'm just going to keep it as 1 over 5 over here. When I look at my variable terms, x to the 6th divided by x squared, right? This is the same as having 6 x's, so 1, 2, 3, 4, 5, 6. I'm going to divide it out by 2 x's, xx, right? Now I see that a couple of these x's can actually cancel out, right? So this x can cancel out, and this x can cancel out. And what I'm left with are these 4 x's, right? And I can rewrite this expression as x to the 4th, right? And so that's exactly what I do over here, right? And so those 2 x's that were in the denominator, they actually canceled out when I had a larger power of x in the numerator. So what I'm left with is 1x to the fourth divided by 5. And so this is going to be the first term that I'm keeping. Okay, let's move on to the next one. I have negative 4 divided by 5, right? I'm just going to deal with my regular numbers first because I know how to deal with negative 4 numbers, right? So when I have negative 4 divided by 5, I can't actually simplify that any further than it actually is. And the reason why I know that is because the GCF of 4 and 5 is just 1. So it's in simplest form. I'm just going to leave it as is, which is why I kept the negative 4 over 5. Now, when I see x to the fourth divided by x squared, right, once again, I think about it in terms of its expanded form. So I know that x to the fourth, this is actually the same as x times x times x times x. It's 4 x's being multiplied together. And x squared is just the same as x times x. So I know that I can actually cancel some of these out, right? So I see I can cancel this x out, I can cancel this x out, and what I'm left with are these 2 x's, which we could rewrite as x squared, which is where I get this x squared from, right? So once again, this x squared actually gets canceled out because it's being divided by a higher power over there, right? So this is another term that I'm going to deal with, negative 4x squared divided by 5 when I'm writing out my final expression. But let's move on to our last term. We have 3x squared divided by 5x squared. All right. So first things first, deal with the regular numbers, right? I have 3 divided by 5. I know that this is in simplest form. The way that I know that this is in simplest form, right? Simplest form is when your numerator, so the number at the top of your fraction, and denominator, the number at the bottom of your fraction, have a GCF of 1, right? So the greatest common factor between 3 and 5 is going to be 1. Now, the next thing that I want to look at are my actual variable terms, right? So I have x squared divided by x squared. Once again, I'm going to write this out in expanded form so I can just clearly see what's going on. So I have x times x, that's x squared. And then in my denominator, I have x squared again, so that's also x times x. Oh, looks like we can actually do something here, right? So it looks like this x cancels out, this x cancels out. No more x's. So I don't actually have to write an x over here. So what I'm left with is just 3 over 5, right? And that's going to be my final term. So let's assemble this all together, right? I take the first term that I simplified, right? My first term, x to the fourth, divided by 5, right? My next term that I simplified, which was negative 4x squared divided by 5, I just brought that negative down as a subtraction sign just to make it look a little bit neater, right? And then finally, my last term, which was 3 over 5, right? And 3 over 5 is positive, so that's why I put that plus sign between them to show what that operation was, right? So my final expression should be x to the fourth over 5 minus 4x squared divided by 5 plus 3 over 5. Now, let's do a check for understanding, right? Pause the video here, try out what we just covered, right? Remember to always simplify your numbers first before you go ahead and simplify your variables. And if you're having trouble simplifying your variables, write it out in expanded form and then see what you can cancel out. Take a minute, pause here, work on your check for understanding. Worked on your problem? Let's work on it together so you can check your answer. Okay, so the first thing that we talked about, right? Let's break up our expression, right? So we're going to break it up by terms. So my first term is 3x to the fifth, right? My second term is negative 15x to the third. And my final term is going to be positive 6x, right? I'm going to divide all of those by 9x. So let's work with my first term here, right? So my first term, let me just zoom in a little bit, right? Okay. So my first term is going to be 3x to the fifth. And then I know that I'm going to keep that denominator as 9x. I didn't do anything to it. Okay? So when I'm thinking about dividing 3 and 9, right, I want to think, what's my GCF? Right? And my GCF between 3 and 9 is 3. So what I'm going to do, divide by 3, divide by 3. To get 3 divided by 3 is 1. 9 divided by 3 is 3. I'm just converting it to a simpler form, right? So if you know how to convert fractions to simplest form, right, just go ahead and do it. That's exactly what I'm doing by dividing up my GCF for my numerator and denominator. Now, let's move on to the next part, right? I have x to the 5th, right, divided by x. I'm a little bit rusty on dividing out exponents, so let me just write it out. So I have x times x times x times x times x, right? 5 x's being multiplied together, divided by 1x, right? Well, I can definitely cancel out this 1x, right? And what I'm left with are these 4 remaining x's. So that's where I get x to the 4th from. So I'm going to write that in my numerator, x to the 4th. Okay? So, looks like we just solved that. All right, let's move on to our second term. Negative 15 x to the 3rd power divided by 9x, right? So, once again, I want to try to simplify my numbers, my negative 15 and 9. And if I don't know how to simplify fractions to simplest form, I want to just think about what's my GCF between negative 15 and 9. When I think about it, my GCF is 3, right? So I'm going to divide out of 3 my numerator, divide out of 3 my denominator. And when I do that, negative 15 divided by 3 is negative 5. 9 divided by 3 gives me 3. Okay, just simplified my numbers. I'm going to move on to my variables, right? So my variables that I got going on here are x to the 3rd and x. A little bit rusty about dividing out exponents. Going to write it out in expanded form again, right? X to the 3rd is the same as 3 x's being multiplied together, so x times x times x. And then I have x, my denominator. Looks like I can cross out one of the x's. What I'm left with are 2 x's left, right, which I can rewrite as x squared, and I'm going to put that in my numerator. Done. All right, that's my second term. Finally, let's move on to our last term. Right, my last term is, let me just remember, 6x, right? I have 6x, positive 6x, right, divided by 9x, right? First things first, deal with the numbers. 6 divided by 9, right? If I want to simplify it to simplest form, I want to think, what is my GCF between 6 and 9? Once again, my GCF between 6 and 9 turns out to be 3. So I'm going to divide out 3 at the top, 3 in the bottom. 6 divided by 3 gives me 2. 9 divided by 3 gives me 3. Great. Now I want to deal with these pesky variables, right? I have x divided by x. I can actually just do this here, right? X divided by x, my x's cancel out. No more x's, right? So this ends up being my final form for my last term, right? So I'm going to string all these along to write out my fully simplified expression, right? So everything that I put in a box is going to be part of my simplified expression. So it's going to start off with 1 x to the 4th divided by 3, okay? Minus, I'm going to just bring down that negative sign and write it as a subtraction sign to make my life easier. 5x squared divided by 3. And then finally, my 2 over 3 is positive, so I'm going to write this plus sign over here and write 2 over 3. And this is my final expression. All right? If you're having trouble with this, I suggest going back to the previous example, right? Or this is a good time to give me a call to ask me what you're struggling with. All right? Good luck, work on your practice problems, and if you have any questions, let me know.